Hi friends, let's discuss something more in the context of the linear programming model. You all know that linear programming model is highlighted about the single solutions for your objective functions. But numbers of times multiple solutions has come. Then one thing you need to learn that what are the conditions in which the multiple solutions will come into picture. Multiple solutions come into picture in two conditions. Just I am writing here, multiple solutions will come in two conditions. That is, the first one is the objective function, the objective function and and one of the constant functions should be parallel to each other. If this is the conditions, then you can find the multiple optimal solution. Second, the constraint should form the boundary of the feasible solution in the same direction of objective functions. If both the conditions will match, then and then only multiple optimal solution will be developed. Let's discuss the same with an examples. The example is maximize the profit of an organization, that is Z. The profit function is Z equal to 8x1 plus 16x2 subjected to the constant function is x1 plus s2 should be less than equal to s1 plus s2, okay, should be less than equal to, I'm just taking the symbol, less than equal to 200. Second constant function is x2 should be less than equal to 125. Third, 3x1 plus 6x2 should be less than equal to 900, and the assumption is the non-negative conditions that is applied for all the variables x1 and s2 should be greater than equal to 0. Just mark it. How, if an equation has been identified in this manner, how you can identify that the particular equation is parallel to each other? This is the objective functions. I just make it yellow. That's why it will be easier for you. And I just take another, the constant function that is here, and we just check it whether it is parallel or not. We have to check it. How you can check it? Suppose there are two variables x1 and s2. To make an equation parallel, then x1 divided by x2 should be, or x1 to make an equation parallel, the x1 and x2 of objective function is 8 by 16. The coefficient need to be divided, and that is 1 by 2. Okay, then the constant functions, suppose I will take the third one, then also x1 divided by x2 equal to 3 by 6, that equal to 1 by 2. Just mark it. Here also you will find the 1 by 2, and here also you will find the 1 by 2. When you make the ratio of the variables, or make the ratio of the variables with their respective coefficient, if both the things are the same, then equations, or you can say that objective functions and constant functions are parallel to each other. Second part, you need to be identify whether the boundary of the constant functions should be in the same line of the objective functions. In the particular case, you just mark it that when you draw the boundary, suppose this is the line diagram of the objective functions. Objective functions means it is a maximization questions. The objective functions always be in the outer line, in the outer side, okay, 1 minute, in the outer side. And when you draw the same thing, you will find constant functions, whatever you identify that need to be in the outer part of feasible solution. Just you draw, you definitely see both the objective and constant functions are in the same direction. If it is the minimization questions, then the direction will be different. One will be towards the origin, because minimization means always you think that how to minimize the cost, and the constant functions, it is outer side of the feasible solutions, then it will not be parallel, or they will not find the multiple optimal solutions. But this is the scenario here. You will find the objective functions is outer side of the directions because it's a maximization problem, and constant functions, it is the outer part of the feasible solutions. So in both the case, you will see the condition is applied in the line of multiple optimal solutions. You will not find the single solutions here. You will find the multiple optimal solutions, because one condition, it is the coefficients are parallel to each other. Objective functions coefficient, when it has been divided, the ratio, whatever the ratio will come, that is 1 by 2 here. The objective functions x1 by x2 equal to 1 by 2, and one of the constant function is 1 by 2. That's why both the cases has been satisfied. So you will find the multiple optimal solutions in your linear programming models. So you should know that in which are the scenarios you will find such type of the things, because it is essential one to understand the different type of the competitive examinations questions in the line of your fundamentals on linear programming. Thank you all.